We're looking at the constant rule. Let me scroll up. We're doing the basic differentiation rules, and we're here at number 1, looking at the constant rule. We're going to look at some different types of notation, like I mentioned moments ago. So if I said f of x is equal to, let's say, -10, and we want to find, yeah, we want to find, hope that doesn't do that every time. Get over there. F prime of x. So remember that the derivative of a constant is 0. The derivative of a constant is 0. All right, what if we had y is equal to, let's say, let's throw in well, all kinds of issues going on here. What is going on? Um, well, I was going to try. Insert. What happened to my equation table? Huh. It doesn't matter. We'll make a number. I was going to use a square root or a fraction. And we're asked to find y prime. Okay. Yep. This is going to become an issue, I think. As soon as I get something going, something else happens. So different notation here, as you can see. So the derivative, it's asking for y prime. That means that we need to find the derivative, and that derivative is 0 because 4 is a constant. Because 4 is a constant. Okay. Oh, there it is, finally. I don't know what happened there. Craziness. Okay, in this particular one here, remember this notation, d over dx. And if we're asked, for example, something like this is saying take the derivative of whatever's inside of these brackets here. And of course, that happens to be a constant. Right? That happens to be a constant. Okay. Well, let's, since I finally was able to bring up the equation bar, we'll go ahead and make this. Let's make that, for example, the square root of 10. Right? Well, the square root of 10 is a constant. Right? It's a constant, and the derivative of a constant is 0. The derivative of a constant is 0. See that? Okay. That derivative is 0. What if you were asked, this is kind of one of those problems, you know, you're asked to find the tangent line at a given point. for example, if you had f of x, this would be like a typical problem on a test. If you had f of x is equal to 4, and it's asking you to find the tangent line, for example, y is equal to mx plus b, and of course we need a point, don't we? And we could just say the point is 1 comma 2, right? And it's asking you to find the tangent line, right, that passes through that point 1, 2. I tell you, that thing is getting annoying. Why that's jumping way over there like that. I'm becoming annoyed with this. All right, I don't know. But if it's asking you to find the tangent line, you should just be able to look at this. Well, it's going to cross the y-axis. This is where it crosses the y-axis, right? And the slope is going to be 0. The slope is 0 at any given point on the line. So if you had 0x, or 0 times x, maybe we should put this in parentheses, plus b, and remember b is where it crosses the y-axis, the y-intercept, so b is going to be what? 2. B is going to be 2. See? So this whole thing just becomes y is equal to 2. Of course, you may have to prove that, and you know, that's pretty simple because all you have to do is find the derivative, and remember the derivative is f prime of x is equal to 0. And when you go to plug in 1 to find the slope, it's still going to be 0, right? There's no x over here to plug it into. So the slope is 0, so you'd plug 0 into here, then plug 2 here, 1 here, and solve for b, and b is obviously going to be 2. See that? So pretty easy stuff. All right, when it comes to dealing with the constant functions. Okay, so we're going to move on to bigger and better things, and that's going to be the next rule will be I believe it's the power rule.